Okay, so you'll notice here I printed out notes for you because it could be a hassle to have to write out all these word problems, all right? So instead I just gave this to you here. So today we're going to be talking about something called angle of elevation and angle of depression. It's kind of an application, okay, a way we can use sine, cosine, and tangent to not just solve like random abstract triangles, but to actually kind of, you know, apply that knowledge in a useful way, okay? So, angle of elevation, angle of depression. Well, you guys already have, bless you, sorry, you already have an idea about what elevation and depression is, right? So, an angle of elevation or angle of depression is the angle created by a horizontal line of sight. Okay, so what do I mean by horizontal line of sight? So like when you're standing, right, and you like look out straight, all right, that is your line of sight. Why is it a line? Because you're kind of like looking out along a straight line, right? And it's your sight because that's what you're viewing, okay? So you like have that horizontal line of sight, okay? And then the actual line of sight, okay? So the horizontal line of sight is you standing, looking kind of just straight out to the horizon. That's the horizontal line of sight. And then there maybe will be an object above you, in which case you would have to like look up, okay? And that would create an angle, right? If you imagine like the horizontal is right here, right? You're like looking out, and you like see a bird or a plane or Superman up in the sky, and you look up, right? And that's an angle of, well, what do you think? Is that elevation or depression? Elevation, right? Because you're looking up, right? Okay. Whereas maybe if you're like on top of a building or something like that, all right? If you would look out straight, that would be again your horizontal line of sight. But if you wanted to like look down at all the small people that are like way below you, okay, angle of depression, all right, because you're looking down from the horizontal, okay? So that's the two different things here. And we'll draw some pictures here to represent that. So we'll kind of divide up the little space there. All right, let's draw the ground, okay, and we'll draw an observer on the ground. Okay, and we'll draw like a cliff, and maybe like a little tree on the cliff, a happy little tree on the cliff. Happy little tree. You guys ever see Bob Ross? Yes, happy little tree. Bob Ross is, if you get on Twitch tonight, I think they start showing his stuff on like 8 p.m. or something like that. You can watch him paint. No, he's passed actually. He died from cancer, sadly. Back in like the 90s, I want to say. But you can watch him paint. It's very like soothing to watch him paint actually.
That was when I was homesick from school. That's all that was ever on TV.
Yeah.
Just watching it all the time.
That's right. Happy little trees, happy little accidents and things. So anyway, so here's the observer, okay? So when you are doing these problems, we need to be careful about like who's doing the observing. What perspective we're kind of measuring from, okay? So since this is our person, all right, we're going to say this is our observer, and so their horizontal line of sight. And I suggest whenever you like do these problems that you draw a picture and you like get it drawn here. So we're going to draw from our observer here a horizontal line of sight. So there's like the horizontal line of sight. Setting up these problems is like half of the battle here, so you need to be able to like draw accurately. Okay? But of course, if this observer wants to view the tree, they have to do what? They have to look up, right? And so we're going to then draw a second line of sight up to the top of the tree there. Okay, and this is called the actual line of sight.
Last one was space.
Because it's where they're actually looking. They're actually looking to the tree.
Yeah. Like an illusion.
Okay. And so this creates... Oh, question? Peripheral vision? So I understand what you're saying. It's more like what we're focused on. You know what I mean? Like, obviously, yes, peripheral vision, like, you can see a lot more than just along a single line. But the idea is more what you're focusing on. If you were to focus out straight in front of you, that's your horizontal line of sight. You're like looking towards the horizon. But then when you focus up and look at that, that's your actual line of sight towards whatever the object is. But absolutely, there is peripheral vision and things like that too. Yeah. We're talking about like what we're focused on. That creates this angle right here. Okay. Now, the typical letter that we sometimes will use to represent an angle, okay, it's a Greek letter. All right, so to draw this Greek letter, you look like a little O, and then you draw a line through it like that.
So a zero?
Okay, so this is an angle right here, okay, and it's a Greek letter that we're using to represent the angle. So I'll even put this, I'll put a little degree symbol up there. Okay, so it's like an O with like a line, a horizontal line right there through it, okay? That Greek letter is called theta, Theta, theta. Okay? That's just the angle. That's for whatever reason, that's the Greek letter that we use to represent. Just like we use pi, pi is actually a Greek letter. It's used their alphabet, right? It's their p sound, I think. Pi is in the Greek alphabet. We use it to represent 3.14, right? 15926, all that good stuff. Theta is the Greek letter that we use to represent angles. Okay? And some like fraternities and sororities use it in their names and things. Okay, so there is a angle of elevation. So I'm going to say here, theta equals angle of elevation. All right. It's because our observer, the person who is observing, or the thing that is doing the observing, okay, from its horizontal line of sight, it has to look up to see the object. Okay. Now notice here, this length. So you can see our triangle right here, right? You can kind of see that triangle in there. Notice that this side of the triangle, it's not the entire height of the tree. It's only the height from the horizontal line of sight up to the top of the tree, right? And that's because when you observe, where do you observe from? Do you observe from the ground? You observe from your eyes. And so you're starting out already up off the ground some before you then look up to see the tree. And so you have to take that into account sometimes for some of our problems. We may have to add in this extra like eye height sometimes. Sometimes we ignore it and we just use it to kind of measure and stuff like that. But anyway. All right, let's look at an angle of depression now. So again, we'll draw the ground. Okay, I'm going to draw a bigger person now. Okay, that's right. And in this case, we're going to be looking at okay, so we draw a big person, we draw like a little bug. Okay, so again, the big person may be like looking out. That's their horizontal line of sight. If they were to like look out towards the horizon, so horizontal line of sight. Okay. But then from that horizontal line of sight, what do they have to do to observe the bug? They have to look down. And so that is the actual line of sight.
And maybe you can use a bunch of mirrors. Straight to the mirror. And
right.
The mirror will reflect off the mirror.
Good. Bless you. Okay. And again, this one's a little bit harder to see, but if we kind of like drop down a perpendicular there, we can have there's another right triangle. You can kind of see it. Okay, we have the horizontal line of sight. We have then the actual line of sight, and it creates this right triangle. And again, we'll put theta in there for this angle measure. And so theta equals the angle of depression. Okay. So it's not depression like sadness, it's depression like you're looking down. Which is kind of like, well, if you're depressed, I guess you do kind of look down a lot, don't you?
No, we feel down.
Okay? Now, we could talk about the human having to look down to see the ant, but since the ant's like a living thing, right, we could talk about the ant having to look up to see the human. And so the ant has an angle of elevation. So if we're talking about the ant, okay, the ant's perspective would be like straight out, there's its horizontal line of sight, and it would have an angle of elevation. How do you think the ant's angle of elevation compares to the human's angle of depression? What do you think is going to be true about those two angles?
That they're equal.
They're going to be equal. Exactly right. So the angle of depression for the human to look down to the ant is the same as the angle of elevation for the ant to look up at the human. Okay? Same thing here too. If we talk about the tree, right, the angle of elevation for the human to see the tree is the same as the tree's angle of depression. Now the tree's angle of depression would be like down this way.
Is it an ant?
Okay? Yeah, if it was an ent or something like that. Exactly right. From the Lord of the Rings. Okay? So you could have the same, that'd be the same angle of depression there. Okay? So, let's take a look at our first problem here. Alright, so a camera is on top of a fire tower and it spots a fire. Alright, so let's draw the ground here and we'll draw our tower. Question?
So why is the angle of depression and elevation not the actual line?
Because that's like what you're actually observing. You're actually like looking towards. So you're actually looking at that thing. Like you don't normally like stand, if you're looking at something, you don't stand and look at the horizon and then try and like catch it in your like peripheral vision. You're normally looking at the thing and your head's tilted down, but you're looking down from horizontal towards that thing.
If you're ignoring someone, you don't look them in the eyes.
So, right. All right, we'll put a little camera up here.
Ooh.
Okay, so there's our little camera. And we'll put our fire over here.
Tiny fire.
Okay. So, Piper, who is the observer here, or what is the observer? What's the thing that's like looking at stuff? The camera, okay, right. So focus is important, right? The camera is looking, okay? So we're going to draw from the camera, our observer, we're going to draw the horizontal line of sight. Okay? So horizontal line of sight from the observer. I'm just going to put LOS for line of sight. Okay? Very good. And then, Antoinette, we have an angle, right? An angle of depression. So that means the camera is going to be looking in which direction? Down, okay? So we're going to draw from the camera, we're going to draw that downward looking towards the fire, and the angle of depression is specifically what measure? Go ahead, Antoinette. What's our angle of depression measure? In the problem, what are we told the angle of depression is? What measure is it, I should say? In the situation here, what's the angle of depression to the fire? 22 degrees. That's right. Okay. So, folks, the 22 does not go here. Does not go here, because what do you measure an angle of depression from? It's from the horizontal line of sight down to the actual line of sight. So here's the actual right here, actual line of sight. So we're measuring down from the horizontal down 22 degrees. Okay, and so then we can kind of finish off our right triangle right here if we wanted to. Okay. Now, how many right triangles do we actually see in this picture here? How many do exist? Yes, two. There's a second one right here. All right. And here's something we could do. So if this is a 22 degree angle of depression, what can we say the angle of elevation from the fire to the camera is?
22.
So we could also label this as 22 degrees if you wanted to as well, right here. they're going to be equal angles. Okay. But we're not interested in that. We're interested in how far is the fire. Oh, the tower is 75 meters tall. So this is 75.
Wait, that's 75 feet.
Well, a tower with a camera, I'd say. Yeah.
Yeah, who saw this camera?
Okay. So if the tower is 75 meters tall, well, that means this height right here of that triangle is going to be 75 meters as well, right? You can see it's like a, if that's 75 meters, this will also be 75 meters as well. Okay? And we want to find how far is the fire from the base of the tower. So that's this measurement right here, right? We want to know what is this measurement right here. Okay? What is that measurement? Well, this is going to be this measurement is the same as this measurement right up here, right? From the camera to that right angle. So we could also find the exact same thing here. That's also what we want to find. It's the same thing. Either from the base of the tower to the fire, or from the top of the tower to like that perpendicular right there. Okay? So let me redraw this triangle here, hopefully in a bit of an easier way, without all this stuff. We have the right angle. We have that this is 75. We have that this is our unknown, and that this angle right here is 22 degrees. Okay, do you see it? I pulled this triangle out and drew that right there. Alright, so Melissa, with this angle and these two sides, okay, 75, what is that? What is that in relation to 22? Is it the opposite, adjacent leg, or hypotenuse from 22? So here's the 22 degree angle. Is this the opposite side, the adjacent leg, or the hypotenuse to that? Sorry? So this is the hypotenuse, right? But you're thinking Pythagorean theorem, though. We got to be careful. We want to use we're not using Pythagorean theorem here. We're using sine, cosine, or tangent. So again, 75. What is that in relation to the 22 degree angle? Is it opposite from the 22 degree angle? Is it the adjacent leg to the 22 degree angle, or is it the hypotenuse of this right triangle? Say again. So the 75 you're saying is next to the 22 degree angle? Yeah, so no, it's not, right? This is the opposite leg. It's opposite from that 22 degree angle. So we have the opposite side, and we want to find, though, what is this side in relation to the 22 degree angle? No, again, trig ratios, thinking that. Is it the, I mean, it is the horizontal line of sight, yes, but I'm talking more like, is it, again, in this right triangle, is it the adjacent leg, is it the opposite leg, or is it the hypotenuse? Which part's this in relationship to that 22 degree angle? Well, we just said 75 was the opposite from the 22 degree angle. Does that make sense then that this would also be the opposite from the 22 degree angle? Yeah, it's the adjacent leg. That's right. Okay, this is the hypotenuse, right? And we don't want that. We want the adjacent leg. So we want the adjacent leg. We have the opposite side. And so what trig ratio, Melissa, has both opposite and adjacent in it? And you can use the SOHCAHTOA up there if you need to. Tangent, that's right. So we're going to say tangent of what angle? Sorry, yeah, I know. What was the angle we're using? So, what's that? Right, we take the tangent of an angle. So tangent of 22 degrees equals, tangent is TOA, so opposite over adjacent. So equals what over what? What's our opposite side from the 22 degrees? 75. Over the unknown, right? We don't know that one, so we'll call that x. Okay? All right, so now we can go to our calculators, and we'll type in tangent of 22. We get about 0.404, which is equal to 75 over x. All right? We put that over 1, and we cross multiply here. So 75 times 1 is 75. 0.404 times x is 0.404x. Okay, and then divide both sides by 0.404. And so x equals 185.6. And I'm going to put squiggly equal sign because it's approximate.
I put 0.40 and I got 187.5.
And what should our units be here? Meters, that's right. Okay, our distances are measured in meters. So there it is. 185.6 meters is how far the fire tower will be. That horizontal distance.
What if we put it in centimeters?
You could do that. It'll be a lot. Okay. So again, you can see, folks, why we were really, emphasizing trying to get that SOHCAHTOA stuff down, because that's what's important here. Not only the pictures are hard enough to draw, but then we also have to use sine, cosine, or tangent to help us find the missing pieces. Okay. Questions on any of that? So again, let me summarize. We drew a picture. Okay. First, from our observer, we drew the horizontal line of sight. Then we drew the actual line of sight to the object, and we wrote in our angle of depression here, 22 degrees. Okay. Since the tower was 75 meters, that means this side would also be 75 meters. Thank you, sir. Okay, and then the actual distance from the camera to the fire is what we wanted to find. And so that was that unknown side length. So we've made us this simple triangle right here. And we just solved the missing side that we wanted. Okay? Let's try another one. Okay. So a surveyor is standing 50 feet from the base of a large tree. So we'll kind of draw the ground again here. We'll draw our little person, the surveyor, and then we'll draw a tree.
Where's the survey?
A lollipop tree.
In the lollipop guild?
Okay? Yes, I'm sorry, Corey. So, if we read the directions here, if we read the situation, it says the surveyor is standing 50 feet from the base of a large tree. So we'll say 50 feet from the base of that large tree. Okay. The surveyor measures the angle of elevation to the top of the tree to be 71.5 degrees. How tall is the tree? All right, so you'll notice here that even though we're talking about a human being, right, and we have a certain height of our eyes off the ground, it doesn't give us the eye height of the observer, so we're not going to worry about that. We're just going to kind of forget about the fact that he or she is measuring from their eye height here. Okay, so we're just going to basically draw our triangle. We're going to say the horizontal then is basically going to be the ground in this case. Okay, we're going to say the horizontal is the ground, and so we're going to look up from the ground to the top of this tree. Okay, so again, the horizontal line of sight is the ground. Okay, and then the actual line of sight's right there. Okay, and the angle of elevation from the horizontal, which is the ground here, up to the actual is 71.5 degrees. Okay. And we want to find
The height of the tree.
the height of the tree. That's right. Okay, so our value that we want to find here is this x. Okay. So there's our kind of picture, but we can pull the triangle out of it there. There's our right angle. So it's basically a triangle that looks like this. Okay, right angle, 71.5 degrees, 50 feet here for the base, and we want to find x. Okay, so there's our picture, but there's our simpler triangle to help us kind of figure this out. Okay, so Donovan, which trig ratio do we want to use here? If we have this angle, okay, what is the x in relationship to this angle? Is it the opposite side, is it the adjacent leg, or is it the hypotenuse of this right triangle? X is opposite? Sorry, x is not adjacent, it's the opposite. Sorry. What's the 50 though? In relationship to that 71.5? Is it the adjacent leg or is it the hypotenuse? It's the adjacent leg, that's right. And so what trig ratio has both opposite and adjacent in it? Look up here. Which trig ratio has opposite and adjacent in it? Tangent. So we're going to use tangent. So we'll say tangent of our angle, 71.5 degrees, equals, oops, sorry, I'm off the screen, there we go. Equals, and then what over what here, Donovan? In this case, what goes on top? Sorry? I still couldn't hear you. The
Opposite over adjacent.
Opposite over adjacent. So yeah, so what's the opposite side from 71.5? Well, what's opposite from the 71.5? Yeah, opposite. So it's the x, opposite side, over the 50, the adjacent side. That's the idea there. Okay? And so then, again, to our calculators, because we don't know what tangent of 71.5 is, so tangent 71.5 is about, 2.988.
So 2.99.
Oh yeah, I'll put 2.989 because I'm going to round that there. And that equals x over 50. Put the 2.989 over 1, and we'll cross multiply. Okay, so 50 times 2.989. We get about 149.45 equals x. So there's our answer. Okay, no extra work necessary.
Can you explain like how the difference between the first one when the horizontal line of sight wasn't at the ground?
Yeah.
And then this one, the horizontal line of sight is at the ground.
Right.
How do you know when to make it come out from their eyeball? You know what I mean?
Right. Yes, that's a good question. So in this case, because we're not given that level of information, we're just going to have to do it from the ground because we don't know what the height of the eyeball of the observer is.
Oh, okay.
So we kind of just have to do it from the ground, so to speak. And the surveyor does have, so a surveyor would have the tools necessary to measure the angle of elevation from the ground potentially to the top of the tree as opposed to just using their eyeballs and stuff like that. So, yeah, that's basically it. It's more like in the context of the problem, it's how much information does the problem give you, I guess, to a certain degree. So,
Is there an easier way to do this?
nope.
Why?
This is as easy as it gets.
It's always an easy way to do it, so don't tell me.
No, Corey. That's not the case. Okay. All right. We're going to skip this next one. We're going to go to another one here. Okay.
If they give us the angle,
Yes.
if the angle's given, then we can pretty much, it doesn't matter, right? Because you have an angle already, it doesn't matter how you draw it. No? I don't know.
Yes and no. Yes and no. Like, for example, I mean, yes, you could have used both of these. I mean, both triangles here you could have, solved in this case. Is that what you're trying to say,
Right,
Ms.
the
Bachman?
first one, the one we didn't solve, it wouldn't matter if we had drawn that at the bottom or not.
If you put the 22 degrees here, you're fine, yes. But the problem is...
Up here, if we would have put the one up higher, if we would have put...
Yes.
It doesn't really matter, actually, because the what they'll give you... Okay, wait.
Well, there is, anytime you're measuring from your eyes, you really do need to include the height up to your eyes in order, whenever you're, doing these measurements. You do need to include that, yes. Because if we were to, more accurately, if we were, to very accurately do this, this length that we'd find here would only be the length from our horizontal, our eye height to the top of the tree. You would need to include that little extra
And I'm
piece.
thinking if they're going to give you those in the word problem, you'll know
Yes,
that.
they will give you that information in the problem. Yes. Okay? All right, so again, we're going to skip this third one. And we're going to go to this next one here. Okay? So, next one. A shark swims 22 feet below sea level. If the shark is 67 feet from the sailboat or a sailboat, what is the angle of depression of the boat to the shark? Okay, so in this case, we've got the water. Okay, and we have a sailboat on top of the water.
And then we got jaws underneath.
All right, right, and we have a shark somewhere down here, so... something like that.
Look, a goldfish spin.
And angry eyebrows. Yeah, you have to have angry eyebrows.
That's a requirement.
Okay. So, a shark swims 20... Well, I'll let you guys finish drawing here and then we'll label it. Okay. So the shark swims 22 feet below sea level. All right. So is that the distance from the boat to the shark? Is that 22? Like this? Is this 22? Yeah, that's not directly below sea level. Below sea level is like from the sea level straight down, and so that would be like this measurement. Okay, is 22 feet.
Wait,
Say again. Okay.
okay, when it says 67 from the sailboat.
Right, yeah. So now, we're told also the shark is 67 feet from the sailboat. So that's the actual measurement from the sailboat to the shark. So if we go from like here to there, okay, that is 67 feet. Okay, because that is the distance, the direct distance there from the shark to the sailboat, 67 feet. And then we're asked to find, and this is different, what is the angle of depression? All right, so now what's the observer here, the shark or the sailboat? Sailboat, okay, the horizontal is going to be like the ground, or not the ground, the water here though, okay? So we've got our kind of like horizontal coming out from the bottom of the boat, okay? And so from that boat's horizontal line of sight, it's an angle of depression, so it means we're looking which direction? Down. So there's our angle of depression right there. We want to know what is this angle. I'm going to call it theta, right? The little circle with the horizontal line through it, theta, T-H-E-T-A. Okay, if you are unsure how to pronounce it, T-H-E-T-A, theta. I think you're saying theta. Okay, so we want to find this angle, and we have these two, and this is a right triangle, right? Okay. So, okay, Robbie, what is this side in relation to this angle theta that we're trying to find? What is this side right here? Opposite, good. And what is the 67 in relation to this angle theta? So it is adjacent, but is it the adjacent leg of the right triangle? It's the hypotenuse. So we have the opposite side is the 22, and then this is the hypotenuse. So which trig ratio has opposite and hypotenuse? Sine. And so we're going to write sine of theta, again, our unknown angle, so theta, sine of theta equals, and then, Robbie, what would be our setup here? 22 over 67. So there's our setup. Sine theta equals 22 over 67. Okay? And then how do we find theta, though? At this point, what do we need to type into our calculator?
-1.
Yeah, sine inverse. So theta equals sine inverse of 22 over 67. So that's where we go to our calculators here. We have to type in second sine. Okay, see the sign to the negative 1 there? 22 over 67. You hit enter, and you get about 19.2 degrees, we'll say. Okay, so that's our angle of depression, 19.2 degrees. Is how far you have to look, or how much you have to look down to see that shark. Okay, and that's your answer. Okay? Questions on any of that?
No.
All right. So again, this is just using SOHCAHTOA. All this stuff here is really using SOHCAHTOA and setting up. Sometimes you're solving for the angle, sometimes you're solving for the missing side.